Hello and welcome to the lecture session on applications of probability. The probability theory is applied in everyday life in risk assessment and modeling. The insurance industry and markets use actuarial science to determine the pricing and make trading decisions. The governments apply probabilistic methods in environmental regulation. Entitlement analysis, that is reliability theory of aging and longevity, and financial regulations. In addition to financial assessment, probability can be used to analyze trends in biology, that is disease spread, as well as ecology. Example, biological Punnett squares. Probability for computer science treats the most common discrete and continuous distributions, showing how they find use in decision and estimation problems, and constructs computer algorithms for generating observations from the various distributions. So these are all the various applications in various fields we can find. It is to name a few. There are lot many applications we can see in the day-to-day life also. So coming to each one of the topics, that is application problems based on the for a binomial distribution, a Poisson distribution, and so on. Let us see one by one. Application problem based on the binomial distribution. There is an agent selling a life insurance policy to 5 equally aged healthy people. And according to the recent data, the probability of a person living in these conditions for 30 years or more is 2 by 3. Calculate the probability that after 30 years, first one is all the 5 people are still living. Second one, at least 3 people are still living. And the third one is exactly 2 people are still living. So this is the question about the binomial distribution. I like how it has to be applied, the binomial distribution, and find out the probability of their existence. Solution. An agent sells life insurance policies to 5 equally aged healthy people. So according to the recent data, the probability of a person living in these conditions for 30 years or more is 2 by 3. So we have the given data is n is equal to 5 and p is equal to 2 by 3. So q, that is 1 minus of 2 by 3, that gives us 1 by 3. Hence, p of x, the formula is ncx into p power x q power n minus x. And we get 5cx, p value is 2 by 3, therefore it is 2 by 3 the power x. And the q value is 1 by 3, hence that is 1 by 3 power n minus x, where n is 5. And x can take any value. The first question is that all the 5 people are still living, that is when x is given as 5. So first one is 5c5 and 2 by 3 to the power of 5 and 1 by 3 to the power of 5 minus 5, it will be 0. That is power is 0, so it will be 1. So when we calculate this, 5c5 and 2 by 3 power 5, if you calculate, 5c5 is 1 and 2 by 3 power 5 is 0.132. This is the probability that all the 5 people are still living. Next, coming to at least 3 people are still living. At least means minimum is 3, beyond that up to 5, because only 5 people are there. 3 is also included, x is equal to 3, 4 and 5. So all the 3 we need to calculate and then add them. So when x is 3, it is 5c3 into 2 by 3 to the power 3 into 1 by 3 to the power of 5 minus 3, that is 2. I would like to show this one now. Let me just write it down and then show. 5c3, the first one is 5c3 into 2 by 3 to the power of 2 by 3 to the power 3 into 1 by 3 to the power 5 minus 3. 5 minus 3, that gives us 2. So 2 by 3 to the power of 3 into 1 by 3 to the power of 5 by 3. So that is the value. Next, similarly, 5 by 4 into 2 by 3 power 4 and 1 by 3 power 5 minus 4, that gives us 1. And if we calculate this one, that is 5c3 means 5 factorial divided by 3 factorial into 2 factorial, that one we have to calculate, and 2 by 3 power 3 and 1 by 3 power 5 by 3, 5 minus 2, that is 2. So when we calculate all these things, we will be getting the answer is 0.791. Let's erase this. Okay, now exactly two people are still living. The same way, when x is put as 2, we will be getting this answer, that is 0.164. This is the answer, we will be getting it. So exactly two people are still living means this one. At least three people are still living means it's 0.191, and all the 5 people are still living is 0.132. Next, let us take an application problem on the Poisson distribution. In the Poisson distribution, the probability of the success will be very low, and then the size of the sample will be huge. That you have to remember. A garment manufacturer knows that, and anyway, in both the cases, we can apply either Poisson as well as a binomial problem also, binomial distribution also. A garment manufacturer knows that the number of flaws per square yard in a particular type of cloth varies with an average of 1.3 per square yard. What is the approximate probability of obtaining a sample of 10 square yard of material with more than 10 flaws? Solution. The probability mass function of the Poisson distribution is defined by P of x is equals to m power x e power minus n by x factorial, and given the mean is 1.3. For 10 square yards, we have m star as m into 10, that is 1.3 into 10 or 13. So the required probability is P of x greater than 10. Now P of x greater than 10, it is very difficult to calculate as I told you. So we can take its complement, that is 1 minus of P of x less than or equals to 10. That will be better. So P of x is x greater than 10 means it is 1 minus P of x less than or equals to 10. We can calculate this as P of x less than or equals to 10 means 0, 1, 2, 3, etc. All that we have to add it, we will be getting this answer. Therefore, we get P of x greater than 10 is 0.748, or it's almost equivalent to 0.75. That is 75% of this one. Next, let us take an application problem in the exponential distribution. So number of days, this is a continuous distribution which you need to remember. Number of days ahead travelers purchase their airline tickets can be modeled by an exponential distribution with the average amount of time equal to 15 days. Find the probability that a traveler will purchase a ticket fewer than 10 days in advance. If x is an exponential variate, given mean is 15, hence mean is given by 1 by alpha, therefore 1 by alpha is 15, so alpha will be 1 upon 15. And f of x is given by 1 by 15, that is alpha e power minus alpha x, therefore we get it and x is greater than 0, and it is 0 in the other case. So p of x less than 10 means like integral from 0 to 10 f of x dx, that gives us 1 by 10 e power minus x by 15 into dx, or 1 by 15 times of e power minus 1 by x by 15 divided by 1 by 15, where 1 by 15 and 1 by 15 cancels, and we get a limit is substituted from 0 to 10, and we get e power minus x by 15 with a negative sign. When 10 is substituted, it will be 10 by 15, and on simplification we get this. Or let me show you this one. This 1 by 15 and 1 by 15 cancels. So what we will be getting is minus e to the power 10 by 15, minus of minus, it is plus e power 0. That gives us 1 minus e power 10 by 15, that is 5 2s are 5 3s are e to the power of 2 by 3, and of course it is with the minus sign, here also with the minus sign. So it is minus of e power minus 10 by 15 plus e to the power of 0, or else 1 minus 1 upon e power 2 by 3. This is what we need to calculate. When we calculate this, we will be getting this answer, that is 0.4866, because 1 by 15 and 1 by 15 gets cancelled, and when x is substituted as the upper limit, that is 10, we get e power 10 by 15 with a minus sign, plus, because minus of minus, the lower limit is minus, then it will be plus e power 0, that will be 1 minus e power minus 2 by 3, or 1 minus 1 upon e power 2 by 3, because minus sign is there, it will go to the denominator. When we calculate this and simplify, we get this answer. Okay. Next, let's go for the normal distribution. In a city, it is estimated that the maximum temperature in June is normally distributed with the mean of 23 degrees Celsius and a standard deviation of 5 degrees Celsius. Calculate the number of days in this month in which it is expected to reach a maximum of between 21 degrees to 27 degrees Celsius. Given mean is 23 and the standard deviation is 5. From the standard normal variate, we have x minus mu upon sigma. So it is varying between 21 to 27, therefore it is p of 21 minus 23 by 5 is less than z less than or equal to 27 minus 23 by 5, and this on simplification we get like this, or z less than or equals to 8 minus of, this is z less than or equals to, because z is greater than minus 0.4, can be also written as z less than or equals to 0.4 with 1 minus. It's a complement we are taking it, and that gives us in total this one 0.4425. It is multiplied with 30. Why we are multiplying is 30. I'll just show you. This is sorry. So this is estimated maximum in the June. So it is for the month, this month. 1 month it will be calculated. So it is multiplied with 30. 0.4425. That is the answer we will be getting. 1 minus of this one, and that is subtracted from 0.7881. That gives us this answer. It is multiplied with the 30 again. So it will be 13 days. So what is this unit is nothing but how many days we will be asking, right? In this month in which expected. Calculate the number of days in this month. So we will be getting out of 30 days, 13 days will be of the required probability. So I have explained about various applications involved in the Poisson distribution. involved in solving the problems. That is applications for binomial, Poisson, exponential, and then the normal distribution. How the various applications we can find in the uh, engineering problems. Thank you.